Welcome to the deep dive.
Hey there.
Today we are diving deep into the future of scalability on Cardano. Specifically, we're looking at this thing called Ouroboros Leios.
Yeah, it's a big one.
Yeah.
And we've pulled together quite a bit for this, especially leaning on a really insightful overview from Pi Lanningham, who's, a well-known dev in the
Yeah.
Cardano space, plus forum chats, FAQs, news, the usual mix.
Right. And our mission today is basically to unpack Leios. What is it? Why is everyone talking about it? Why is it potentially so important?
And crucially, what it might mean for you, whether you're a Cardano user, a developer building stuff, or maybe you're running a stake pool.
Pi's take really frames the why nicely, doesn't it?
It really does. It helps clarify the core challenges Leios is trying to solve.
Okay, let's get into it then.
So first things first, the foundation. Cardano runs on Ouroboros.
Right, the proof of stake protocol family, known for being peer-reviewed, energy efficient.
Exactly. That's the bedrock. And the version running right now, the one on mainnet, is Ouroboros Praos.
Okay, Prowse is now. So Leios fits in. How? Is it replacing Prowse?
It's, think of it as a future version, a specific next-gen variant within that same Ouroboros family. It's still very much in the research and development phase, so not live yet.
And its main goal, what's the big promise?
Throughput. Its primary objective is to massively crank up Cardano's transaction throughput, how many transactions it can handle per second, and alongside that, make better use of network resources.
I've also heard about something called Paris. Is that related or different?
Good question. They are distinct but related. The sources sort of position Paris as focusing more on the consensus mechanism itself, making it more modular, maybe more efficient internally.
Okay, like improving the engine parts.
Kind of. While Leios is laser-focused on the output specifically, enabling massive parallel transaction processing for huge throughput gains, you could maybe see Paris as laying some groundwork, making the system more flexible, which Leios could then build upon. But Leios is really seen as the long-term answer for scaling transaction capacity way up.
Gotcha. Paris is maybe foundational improvements. Leios is the high-speed highway built on top.
That's a decent way to think about it, yeah.
So why the urgency? Why is this huge increase in capacity seen as so vital? I mean, Cardano works today.
It does work, absolutely. But Pi Lanningham's write-up gives a really strong case for why Leios, or something like it, is pretty crucial for the network's future health. Long-term sustainability is a big piece of it.
Sustainability. Okay, that sounds like we're talking economics, node operators.
Exactly. Pi points out this key challenge. Stake pool operators get paid through block rewards. That's new ADA being created, and transaction fees. But the block rewards, the new ADA part, that's decreasing over time by design.
Okay, so eventually, transaction fees need to make up the difference for SPOs to stay profitable and keep running their nodes.
Precisely. And here's the kicker from Pi's analysis. Based on how things look now, just to maintain the current level of economic incentive for node operators purely from fees, the network would need to be processing something like 50 transactions per second.
50. Wait, Prowse currently peaks at, what was it, around 10 TPS.
Yeah, roughly 10 TPS under good conditions.
Wow. So a 5x increase is needed just to cover the gap left by diminishing block rewards, economically speaking. That's sobering.
It really frames the scale of the challenge, doesn't it? Because if running a node becomes unprofitable for too many operators, they might shut down. And that starts to erode decentralization, which is, fundamental to Cardano.
And Leios is positioned as the main solution to deliver that needed capacity.
That's the idea. It's the leading proposal designed to provide that huge step up in throughput. It creates the potential for the network to handle enough transactions to generate those necessary fees.
But potential isn't guaranteed income.
Right. And Pi is clear on this too. Leios provides the capability, the infrastructure. You still need actual adoption, real businesses, real users, bringing that transaction volume onto the network to make it sustainable. Build the highway, hope the traffic comes.
Makes sense. It enables sustainability, doesn't guarantee it. What about other angles? User experience?
Yeah.
Developers?
That's the other big driver. Pi touches on this. You see it in forum discussions too. Right now, with Prowse limits, dApps and users are basically fighting for space in each block. There are bandwidth limits.
Yeah, I've heard devs talk about that. Transactions getting stuck, user experience suffering, especially if something is time sensitive.
Exactly. It's frustrating for users and can even push developers away. Leios aims to fix that by providing scalable and elastic capacity. The vision isn't just handling more load, but handling it gracefully. So instead of a few apps clogging the pipes, you could potentially have thousands of dApps running smoothly side by side.
So developers can build without constantly hitting the ceiling?
Yeah, much less worry about network traffic jams impacting their app's usability. That's a huge potential win.
Okay, the why is compelling. Sustainability, better UX, more dev freedom. But the how? How does Leios actually achieve this jump from maybe 10 TPS to potentially thousands? That sounds like a fundamental change.
Yeah, it absolutely is a fundamental shift. It moves away from the largely sequential way Prios works, where one leader builds a block every 20 seconds towards massive parallel processing.
Is that where those analogies come in, like the factory assembly line or singing in rounds?
Yeah, those capture the essence pretty well. Instead of one worker slowly building the whole widget every 20 seconds, you have multiple stations working on different parts simultaneously.
Yeah.
Or different groups singing parts of the song concurrently.
And that means different kinds of blocks, not just the one type we have now.
Correct. Leios introduces three main types of blocks that work together in this pipeline. First up, input blocks, or IBs. These are generated really frequently, maybe like 5 per second, constantly streaming in from across the network, and they're produced in parallel. Their main job is to carry user transactions. Think of them as the raw materials arriving at the factory. They're not huge, maybe 100, 350 kilobits each.
Okay, a constant stream of transactions packaged into these input blocks. What's next?
Then you have endorsement blocks, or EBs. Nodes also produce these frequently. Their role is to look at the input blocks they've seen, check they're valid and available, and essentially endorse them by including their unique IDs. They're like the quality control checkers on the assembly line, verifying the inputs.
And they reference each other.
Right. EBs refer back to previous EBs, which helps ensure that even if some nodes missed an IB initially, it gets picked up and accounted for down the line. It adds robustness.
Okay, IBs bring transactions. EBs check and confirm IBs. What's the final piece?
That's the ranking block, or RB. This one feels a bit more like the Prios blocks we know. It's produced less frequently, on average every 20 seconds, through the usual slot leader lottery. The RB is the supervisor. It looks at all the endorsed input blocks it's aware of, puts them in a final definitive order, and essentially ranks them, finalizing that part of the ledger.
So a transaction isn't truly final and spendable just because it's in an input block. It needs to make it into a ranking block.
Exactly. That's the pipelining effect. You have IB creation, EB creation and endorsement, and finally RB finalization, all happening concurrently, but shifted in time. The network is constantly processing a high volume of incoming stuff, but the final settlement, the point where a transaction is irreversible, still happens with that RB every 20 seconds.
But you might see it faster in your wallet.
Potentially, yes.
Yeah.
Getting into an IB and then getting endorsed by EBs gives an early signal of confidence. So your wallet might show a transaction as pending or even update a balance much sooner than that final 20-second confirmation, which improves the perceived speed for the user. So summing up the advertised benefits, obviously much higher throughput, the lower latency for that initial confirmation signal, a better user experience overall, more flexibility for nodes, plus some under-the-hood improvements like enhanced cryptography, and it's all being rigorously tested with simulations and formal methods.
Sounds great. But okay, let's talk trade-offs. Because
Yeah.
scaling like this, it's never free, right?
Right.
What's the catch?
Definitely not free. And this is where the community discussions, the forum threads we looked at, get really active. There are significant trade-offs. A big one is the increased demand placed on the people running the network, the state pool operators.
What kind of demands? More powerful computers?
Yes, more CPU power, definitely. Because nodes now need to process all these parallel streams of IBs and EBs, not just one block sequence. They'll also need way more bandwidth, both incoming, to receive all this data, and outgoing, to share their own blocks and endorsements.
And storage. I saw some worrying numbers mentioned in forum posts.
That's a major concern raised, yeah. Some estimates, especially for very high target TPS numbers, suggest annual storage needs could balloon, potentially hitting like 14 terabytes a year or even more.
14 terabytes a year. For someone running a small pool, maybe from home, that's a serious jump in cost and complexity. Could that push smaller operators out? Increase centralization?
That's the fear expressed by some, absolutely. If the hardware and bandwidth costs go up too much, it could become harder for smaller, independent SPOs to compete, potentially leading to more state concentration in larger operations. Now, it's fair to say there are other efforts happening like UTXO-HD aiming to tackle ledger bloat and storage efficiency specifically. So the hope is maybe those can mitigate this particular pressure point. But it's a real tension, a definite point of debate.
What about just the complexity of the system itself? 3 block types versus 1?
That adds complexity, no doubt. More moving parts means more potential places for bugs to hide or for unexpected issues to crop up during implementation. The heavy reliance on simulation and formal verification is meant to catch these early, but it's still a risk factor.
Okay, and Pi Lanningham, in his overview, really highlighted one specific challenge as the, quote, last major design hurdle, the transaction conflict problem. Can you unpack that?
Right, this gets to a really fundamental tension Pi laid out. In Prowse today, Cardano has this nice feature of deterministic transactions. Mostly, if your transaction fails, you don't pay a fee.
Yeah, that's a big plus compared to, say, Ethereum, where failed transactions still cost you gas.
Exactly. And Pi explains, Prowse can manage this because block production is relatively slow and sequential. There are quiet periods, time for the network to sort out potential conflicts before a block is finalized. Minimal wasted work. But now imagine Leios. Thousands of transactions potentially hitting the network simultaneously and all these parallel input blocks.
So if you and I both try to spend the exact same funds at roughly the same time?
Our conflicting transactions are much more likely to get into different input blocks before the network nodes have had a chance to gossip and realize there's a conflict. Resolving that after the fact, especially without making someone pay for the failed attempt, becomes way harder at scale.
And Pi mentioned this makes the network more vulnerable to denial of service, people just spamming conflicts.
Potentially, yes. It increases the sensitivity to adversaries trying to deliberately create wasted work by submitting conflicting transactions.
So does this mean Leios might have to sacrifice that you don't pay for failed transactions ideal?
This is the core trade-off Pi identifies. He argues pretty strongly that achieving the very high throughput targets of Leios, while also keeping the network secure and decentralized, probably means you can't also have perfectly deterministic free-on-failure transactions. Something likely has to give a little.
So users might, in some cases, pay a small fee even if their transaction ultimately fails due to a conflict.
That seems to be the likely direction, or at least one strong possibility being explored. Pi's point is that you can't optimize perfectly for all three. Extreme throughput, perfect determinism, and robust security decentralization simultaneously. A compromise is needed. And importantly, he stresses this isn't a decision for the engineers alone. The community, SPOs, DREPs, users will need to weigh these trade-offs and decide what balance they're comfortable with.
What kinds of solutions are they looking at for handling these conflicts then?
It's an active research area. Pi touches on a few possibilities. Things like deduplication, just dropping duplicates if seen early, coloring, kind of partitioning transactions, but maybe not fully solving the adversarial issue, sharding, which is super complex, involves splitting the ledger state, probably only needed for the absolute highest TPS goals, and then collateralization.
Collateralization.
Yeah, Pi described this as maybe a simpler, more pragmatic approach, particularly for the initial Leios throughput goals. The idea might be that you put up a tiny bit of collateral when you submit a transaction, and if your transaction causes a conflict and wastes network resources, you might forfeit that small amount. It puts a bound on the potential wasted work an attacker could cause. But again, the exact mechanism is still being researched and debated.
Okay, let's zoom out again. Thinking about our listeners, who is Leios really for? Who stands to gain the most, and who might feel the pinch from these trade-offs?
It's really aimed at benefiting the whole ecosystem, but the effects will feel different depending on who you are. For you, the average user, the hope is faster feeling transactions because of those quick confirmation signals from endorsement blocks. Longer term, if demand meets the new supply, maybe lower fees, and definitely a more reliable network that doesn't slow down as much during busy times.
Okay. What about developers building dApps?
For them, Leios could be huge. It means potentially having way more headroom before hitting network capacity limits. They can design more ambitious apps, apps that need more transactions, without worrying so much about congestion ruining the user experience. Less competition for block space is a big deal.
And the stake pool operators, we talked about the challenges.
Right. For SPOs, it's a double-edged sword. The upside is the potential for significantly more income from transaction fees, assuming transaction volume grows to fill the new capacity. The downside is definitely those increased operating costs. Better hardware, more bandwidth, potentially much more storage needed, higher stakes, potentially higher rewards.
And finally, the big picture view. For the Cardano ecosystem as a whole,
Leos is really framed as essential plumbing for long-term sustainability. It's about providing the raw capacity needed for Cardano to grow, to onboard potentially millions more users and thousands more applications, and to ensure the economic model can support the network's security and decentralization well into the future as those initial block rewards fade away.
So where are we with Leos right now? Is this coming soon? Can we expect it next quarter?
Oh, definitely not that soon. The sources are all very clear. Leos is still deep in research and development. It is not production ready. But progress is being made. They've run simulations, even used AI agents on testnets to hammer the system with activity. Pi's posts and the IOG research updates show heavy use of sophisticated simulation tools in Rust and Haskell, plus formal methods using math to prove properties of the system. It's very rigorous.
Right, that typical Cardano approach. So what's a realistic timeline look like?
Based on reports and general community sentiment, we're likely talking up to 2 years, maybe more, before a full mainnet deployment could even be considered. They're being methodical, focusing on getting the design right, and thoroughly tested.
And what are the steps between now and then? How does it actually get deployed, if it does?
Well, the next phases involve more simulation refinement, then drafting a detailed Cardano improvement proposal, a CIP. That CIP will lay out the full technical design, the parameters, and crucially, those trade-offs we discussed for the entire community to review and debate.
So the community gets a formal say.
Absolutely. After the CIP discussion, assuming things move forward, there would be prototyping, building out implementations, running specific test nets, maybe public ones for stress testing. Pi hinted at that. And then the final decision comes down to a vote by the Cardano community, the SPOs, the reps representing delegators, and potentially delegators directly, deciding whether to adopt the upgrade and under what specific parameter settings.
All right, so that's our deep dive into Ouroboros Leios. It's a really complex, fascinating proposed upgrade.
Yeah, and a prime example of that research-first, rigorous engineering approach Cardano takes, really digging into fundamental blockchain problems like scalability, with key insights coming from developers like Pi Lanningham, who are up in the trenches.
It definitely promises some major improvements, the kind needed for Cardano's long-term health and ability to handle mainstream adoption.
But, as we've discussed, it also brings these significant technical and economic trade-offs to the forefront. Node costs, network complexity, and that really tricky balance around transaction determinism versus raw throughput. These are active debates the community is having right now.
Which leads to maybe the most interesting question for you listening. How does a decentralized community navigate these kinds of choices? When you have deeply held technical ideals, like perfect transaction determinism, rubbing up against the very real practical need to scale massively to stay competitive and sustainable, like Pi outlined, how do you strike that balance? What weighs more heavily for you?
Definitely something to think about.
Thanks for joining us for this deep dive.